We certainly don't want to continue to use fossil fuels, but it will take some time before we can completely, of course, rid ourselves of them, so to speak. But there's nothing that prevents us from switching to entirely 100% renewable methanol.
As the world wakes up to the climate change crisis, scientists are looking for ways to cool our world. Part of the problem is our reliance on fossil fuels. Transport accounts for 25% of global CO2 emissions. One way to utilise this greenhouse gas is to turn it into a valuable commodity, but that takes enormous amounts of energy. It helps if you're in a country where 100% of the electricity comes from renewable sources. I'm Emma Keeling in Iceland, where carbon dioxide is being used to make a carbon-neutral fuel. Just outside of Reykjavik is Carbon Recycling International's demonstration plant. Woo! Balmy day in Iceland, Benedict?
Yeah, we call it a normal summer day. So all the process happens in our production plant, but first what we need to do is to get the CO2. And the CO2 comes from this geothermal power plant, which is only 700 meters away, which is using volcanic activity, steam that is formed by the volcanoes underneath our feet, as a power source to make electricity and make also heating hot water for the nearby municipalities. And there are a couple of byproducts that come up with the steam, and one of them is sulfides or hydrogen sulfide, which is has the rotten egg smell, and then this invisible molecule CO2, which is also emitted into the air, but we want to borrow that molecule and use it in our process.
You go first. Then I've got something to fall on, Benedict. Built in 2012, CRI became the world's first company to produce and sell methanol made from waste CO2. This is your demonstration plant, so it's not huge, but how much methanol are you making here?
Yes, this was a big leap forward for us to go from lab scale to this scale. And here we can make 12 tons per day or 4,000 tons per year, which is still small in the context of chemical plants or let alone oil refineries, but it's a big leap forward in terms of the development of this type of process and technology.
So 4,000 tons of methanol, what's that equal to in oil, say?
So people usually measure oil in terms of barrels, so it's about 15,000 barrels of oil equivalent per year. But if we look at it in terms of the number of cars that are now able to drive on what is virtually electricity, because we are transforming electricity into a fuel. So it's like we would have put 2,200 to 2,500 electric cars on the road in one go with the consumption from this plant. And then eventually we'll get into the same region as, for example, methanol plants are today, which are using natural gas or coal. So then we're talking about 1 million tons of methanol per year, or 1.5 million tons of CO2 that we would be reprocessing. But this is still, of course, one of the most promising technologies to really go to mega scale in that sense.
Looking at the plant's operational screens, it's hard to understand how that technology works. Instead, we're going to leave the plant and head into the lab. To make methanol, they take CO2 from the geothermal plant and hydrogen, which is created at CRI's plant.
Now we have to see where the other reaction partner is coming from, which is molecular hydrogen. Normally it's made by reforming of hydrocarbons, but that's a non-sustainable way. So we are looking at something which is called electrolysis. And it's
hydrogen is extracted by passing an electric current through water.
And if I turn on the electricity now, it should evolve some bubbles. And as you can hear and as you can also see, there are some bubbles forming, and this is oxygen and hydrogen that we are forming here. So this is basically our second reaction partner that we're producing here at the moment. So now you know how you get our CO2, our hydrogen, and basically we now have to combine them. And this is going to be done in a reactor that I'll show you here.
You've hidden your reactor in a cabinet.
Well, this is because of safety issues, of course. I mean, we're doing that at high pressure. You can't do that at ambient pressure. So we mix the two gases that we now produced, so CO2 and hydrogen, and compress them to a certain reaction pressure that we need, and then introduce them in our reactor. And this reactor is filled with a catalyst. And this catalyst looks like small pellets that we are using. And that's made of different materials. Mostly those are metals.
Okay. But this is top secret because this is all part of your...
Well, it's a mixture of metals that are, I mean, I can tell you that there is, for example, copper in there and zinc, but of course I won't give you the exact mixture because that's protected by our property, intellectual property. So these are basically in here.
Okay.
And we introduce the reaction gases, which is hydrogen and CO2, from the top. They are introduced here and heated to a certain temperature and react on the surface of this catalyst to accelerate the reaction rate. After the reaction in the reactor, we basically cool it down to ambient room temperature. And methanol is a liquid at room temperature. Here you can see the crude methanol catch pot, basically. Crude methanol is basically a mixture of 50% water and 50% methanol.
And the crude methanol comes out and
Exactly.
then you split it.
Exactly. So crude methanol, in theory, can be used, for example, for a methanol fuel cell, because there you need water and methanol. But what we do is, as we are using it mostly as a fuel additive or as a fuel, we purify it by distillation.
The end product is clear and clean.
The difference between methanol, or burning methanol, and burning a hydrocarbon such as heptane, you can really see that it's a clean burning fuel. So what you see is that you don't produce any pollutant, such as soot, what you normally get if you burn diesel or gasoline.
Methanol is on the left, and its blue flame shows it contains no impurities. So are you building plants elsewhere?
We have started a couple of projects abroad that are quite limited, small in scale. One in Germany, where we were using CO2 from a coal-fired power plant. And we were showing that you could actually produce with fluctuating wind energy methanol from that resource. And now we're building a plant up in Sweden, in the north of Sweden, in combination with a steel plant. And we're going to use both hydrogen and CO2 from the steel manufacturing process. So basically transforming those resources into methanol.
Methanol can replace petrochemicals in a variety of products, including paints and plastics. But right now, it's helping me get to the airport. What percentage of the fuel used in this car is actually methanol?
This car is designed to run both on 100% gasoline as well as 100% methanol. So right now, when we're driving, it's on a 100% methanol. Most petrol cars can actually safely take up to 20% methanol, and then the rest would be 80% gasoline. But you also have what are called flex fuel vehicles, which can take much larger amounts, because then the engine can actually adjust to the amount of oxygen that the fuel contains.
So are there any emissions created from using methanol?
Even if we have 100% renewable energy, we still have a tiny amount of CO2 embedded in the energy. So we do deduct that. So we basically say, from a well-to-wheels perspective, we're reducing carbon emissions by 90%, so not quite 100%.
So if methanol is as great as it sounds, do we really need fossil fuels anymore?
We certainly don't want to continue to use fossil fuels, but it will take some time before we can completely, of course, rid ourselves of them, so to speak. And but there's nothing that prevents us from switching to entirely 100% renewable methanol.
It's finished. But don't worry, we've got a lot more Razor stories for you. All you need to do is like, comment and subscribe, and hit the bell button below for notifications. We'll see you next time.